much for the introduction. Thank you all for being here and for the interest in the topic. So let's get started right away. So as you know, I'm Raffael. I'm data engineer at Scout. So I joined Scout in December 2016 and have had quite a blast at this company from then on. So as you can see, this Scout 24 AG is a group of companies actually. And this is what makes it so exciting to work there, because you have Immobilien Scout, Auto Scout, Finance Scout, and also Scout 24 Media. And the data engineering team per se is set up in a cross-vertical fashion. So we have parts of the team sitting here in Munich at Auto Scout, where I'm located. And there is another part of the same team sitting at Immobilien Scout in Berlin. And the challenge here, and also what makes it so exciting, is that all the infrastructure, all the architectures that we built are supposed to be applicable cross-vertical. So they should benefit the entire Scout 24 group. And just very shortly, what do? We support people with big life choices like buying homes, renting apartments, or buying cars, and we have platforms to support that. So the data engineering team per se, what do? We do many things, but among the things we offer is a data platform. So this data platform consists of a data lake that we have heard about in today's keynote already. And around this data lake, we built infrastructure and tooling for easy data access, such as to provide this data for analysis to all of the internal customers, all of the teams within the group. So how does it work in particular? So if we look at the analytics landscape at Scout, we can kind of go bottom to top. So you have a storage layer that would typically be your data lake. Since we are running on AWS, this storage layer is S3. It's actually good because it provides high durability and also almost infinite scalability. So they always tell you that you won't run out of space. So, this works well for us. But if you have this set up, and we have it set up across accounts, so in a multi-account environment, so part of this data lake is living in an Auto Scout account, and another part is living in an Immo Scout account. And of course, we need to provide processing infrastructure for this. So this processing infrastructure is based around Amazon Elastic MapReduce, EMR. It's not the plain old EMR cluster that you might get from AWS. We have built things and software around that to actually adapt it to the Scout setting, but in the core, it's a MapReduce cluster. And on this cluster, we offer the following processing engines. We have Presto running there. We also have Hive, if users choose to use that, or Spark, which is the much better option for like ad hoc analytics. Up top, we have MicroStrategy as our central reporting solution. So MicroStrategy actually runs on top of a Presto cluster. More about that a bit later on in the talk. And then at the very top, you have the users that would either access this data via MicroStrategy to create reports, or do some ad hoc analytics with these cluster solutions that we provide them with, and then they have the full choice between these three processing engines. So the rest of the talk will actually be about easy data access. So we actually have many analysts using this analytics infrastructure, of course. And to analysts, a relational view on the data is actually very familiar. So what we've built at Scout is kind of an intermediate layer here of table structures, basically a high Metastore that can be used by these systems. And what this provides to the analyst is that they don't actually need to know about how the data is structured in the data lake. They just see the tables and can join them, can do their analysis on them. So if you set out to do such a thing, such a central Hive Metastore, there are actually some challenges to solve first. So, of course, this metadata should be kind of persistent, right? And it should provide a unified view of all the data that we offer for analysis. So, and it has to work in a multi-account setting, as I've said before. So, by default, you get that with EMR, but as you might know, on EMR, if you use like the standard Hive Metastore, you get an embedded Derby instance, and it's actually, the metadata is first not unified because each cluster will have generally a different set of tables. And it's also not persistent because as soon as this cluster goes down, you lose the metadata, right? And you don't have this view anymore on your data. So that's not good. What we would like to have is something more like this. So these gray boxes that you see here, they actually represent AWS accounts. And we would like to have this metadata living in an RDS instance, just a plain Aurora instance, small database over there. And this instance is long running and is supposed to be accessed by all of the EMR clusters we might have running in our accounts. The challenge here is that at Scout we have about 50 AWS accounts overall. And we would like to give our users the full authority where they run their infrastructure. So it should be possible to do that. So if you're going to share resources cross-account like this, AWS will tell you best practice is to actually use VPC peering, right? But in our case, this was not an option because for historical reasons, the VPC ranges, so the network ranges for AutoScout and InnoScout accounts overlapped. And this actually prevents you from doing that. So we had to come up with a different kind of solution. And this solution is to actually, it might sound weird, but we will get to that, to make this RDS instance public, so accessible from the internet, from the outside, right? And then to just be really careful about security to make this cross-account access work. And of course, since you see like 50 accounts, nobody wants to do any manual changes here, especially since they affect security. So all of this should actually be automated and done via CloudFormation. So, and what you see here is actually the approach that we chose for this. So the EMR clusters don't access this RDS instance directly, but each account will have an EC2 instance booted up that runs a reverse proxy that kind of feels to the EMR cluster as if it's the database itself, but it actually just relays the metadata queries to the actual central Hive Metastore and gets the answers back to these clusters. And now to the way how we design for security and how do we actually ensure that nobody can read our data, even if this instance is public. So the first thing I should say here is that the security group by default, when this Metastore is launched, is actually very restrictive. So there's no access allowed from anywhere, even though it has a public IP. And now, if we just go back, I will just take two accounts, exemplary, one of these accounts that you see over here, and the account running the central Hive Metastore, and we will take a look at what actually happens if such a proxy instance is booted in an account. So how did we solve that? So you can see the H8 proxy, this is what we use here for the reverse proxy. It boots up. Then it actually triggers a CloudFormation custom resource, which in itself triggers a Lambda function. And this Lambda function sends a create event containing two pieces of information: the public IP of this instance and some credentials that this account would like to use in order to get access to the Metastore. So this comes into an SMS topic. This is just the push notification mechanism that AWS offers. And in itself, on the other side, triggers another Lambda function. And this Lambda function then, if you take a look what it has to do, it will automatically allow ingress access to this specific, this one IP of this HA proxy instance on the database port, 3206 in this case. And it will also create a database user using the credentials that were requested by the account. And it will give this database user the right to connect as long as the connection stems from the public IP of this HA proxy thing. So this is actually how we ensure that everything is all right, because we are now isolated on two different layers. The security group protects from accessing just from anywhere, right? And the database user and the database password actually protect us on a different level, just because you have to know these credentials to even connect to the database. And this is how, if this instance then boots, it's a long-running instance, any EMR cluster could be booted in this account and would get access to the central Hive Metastore, right? So now we can take a look at what actually happens if we decide to shut this instance down. So there is an inverse process running here. So the shutdown event happens. This again triggers this custom resource here. And the custom resource then sends a delete event so that the Lambda function will know what to do with this information, which again contains the public IP of this proxy and the credentials that were used for this account. And what this Lambda function then does is revoking the access that it previously granted, because the HA proxy is not there, obviously, and delete the database user and revoke all the permissions that it had previously. And this is how we ensure that we keep security tight in an automated fashion. Actually, this is a bit of a simplification, because this little EC2 instance that you see here, this is actually not a single instance. It's an ECS cluster running in a highly available manner, and also allowing for zero downtime deploys, because as you might know, this is a single point of failure. If this goes down, all EMR clusters in the account lose access to the Metastore. We don't want that to happen, and still we want to have the full flexibility of doing like software updates at runtime. So yeah, this is how we did it. So it's all based on CloudFormation and lots of custom resources over there. And it actually works quite well for us because it's a low maintenance piece of infrastructure. It's of course, we would have wished for an easier way to be there, but under our circumstances, this was what we came up with. And of course, we have to briefly talk about like access management and access rights here. So this picture you already know, we've seen it before. So on S3 level, we actually have bucket policies that will grant or restrict cross-account access, because lots of these clusters will be running in an account that's different from the account where we have the data lake. And of course, they need certain access permissions, right? So these bucket policies, again, completely automated management of these, they take care that this is actually possible. And then, on the other hand, we have above this table layer, for certain of our access mechanisms, particularly Presto, a way to restrict this table set to a subset of tables that a particular user should be able to see. This also works quite well, and is another security mechanism here that we've implemented in order not to show just anything to anybody, right? So to summarize, we have a unified, consistent view of the table definitions that we have over our data lake. If somebody makes changes to these table definitions, all of the rest of the company immediately benefits from them because they are central, right? And yeah, and you can run clusters in any AWS account without even caring about what goes on in the background. So this is completely transparent to our users. It's actually handled in the background. And the table layer is understood by all the processing engines we use. Of course, Hive is not state-of-the-art anymore, but the Hive Metastore is actually something that is still very vibrant in the big data community. So we like to keep using it. And again, deployment is automated via CloudFormation, and I've just shown a very quick tidbit of how the registration and deregistration of these processes work. So that's all I have for now. I'd love to hear some questions from you guys, and we can go into detail on separate topics. It was a very high-level discussion. I can go into detail on anything that you might want to hear about.
Thank you, Raffael. Any questions? Bitte?
There's actually a question about your data lake. So you store everything on S3
Yes.
as a file system, but where does the data come from? So you push all your CRM data.
That's a very good question, and there will be another talk tomorrow about how we make this happen and about the data landscape in Metastore, actually, by a colleague of mine, Sean Gustafsson. If you're interested about where the data comes from, how we made the cultural change happen within the company to make the data lake work, I refer you to this talk. I can just tell you very briefly is that this data comes basically, so we provide the data lake itself and tooling around it, but we don't own the data in the data lake. So mostly the owners are different teams within the companies that we have in the group, right? And what we then do is to, for example, offer them with easy ways to write data into the right paths in the data lake. So we have naming conventions in place that make it easy for people to determine where the data should live. We have CloudFormation templates readily usable with Kinesis fire hoses and whatnot that allow to push data in real time as you might see fit. And of course, we also thought about GDPR. So yes, we have like sensitive data in the data lake, but it's not exposed to analysts. So this has very restricted access rights. So only a handful of people can even read this data, right? But we still keep it there. So hopefully that kind of answers the question. Or
Yeah.
You mentioned before Hive is not state-of-the-art anymore.
Yeah.
What is state-of-the-art?
So typically, so why isn't Hive state-of-the-art anymore? It's just because as a processing engine behind Hive, you have MapReduce. And MapReduce is like, it was invented 2004, I think. And it's great for batch processing. So if you have nightly jobs where you don't really care about fast response times, this is your friend still, because it's very robust and it's actually good. But for the types of ad hoc analytics that the people do for us, and you have to remember these clusters that we offer, they are really to be used by human users. The response times that Hive offers, they are actually suboptimal, because you can get much faster response times using systems like Presto or even Spark, which both also understand the SQL nature of this metadata. That's why I said that.
And then you talk about table layer. Is this in the context of relational tables? Or?
Yes, so of course it's not relational tables per se, because it has nothing to do with relational databases, but it looks and feels very much like relational tables, because you can then use Hive SQL or Spark SQL, or even the Presto ANSI compatible SQL dialect to manipulate your data just like you would in a database. Just that the processing engine is something that scales horizontally, right? It's not really a database, and it doesn't provide any like nice asset guarantees that we come to use and love from traditional databases. But still, it does its job pretty well for these kinds of analyses.
Then a bit old-fashioned, why not using immediately a relational database?
That's, of course, it's not like relational databases are dead. We use them throughout the company for many use cases. And to be honest, like whenever the amount of data is small enough, I would always go for a relational database, just because of the nice guarantees we get and the 40 plus years of research that went into optimizing these things, right? So Hive or even Spark or even Presto can get nowhere near to the response times that you will get with a reasonable amount of data from a traditional database. But we have to move to these big data technologies when the amount of data becomes too big to handle, right? So you can partition relational database tables, but there are limits to that, right? And the nice thing about these distributed systems and all of these systems that I've talked about today, they fall into this category. They provide horizontal scalability, which means that if you're willing to invest more money, you can basically handle any amount of data you like, right? With the same kind of system and the same kind of code that you write. You write your code once and it gets automatically distributed over your infrastructure. So that's kind of what's nice about these.
Good, then thanks again to Raffael. Thank you, for your valuable presentation, and we move on to the next one.